Hi math friends! In this video, I'll teach you a very straightforward approach to factoring trinomials where the leading coefficient is a number other than 1. I'm not going to show you gimmicks. I'm just going to show you a process that makes sense and gets the job done. Ready to get started? Let's go! Multiplying and factoring are just reverse processes. On the left, the binomials multiply x to x. Nothing more complicated than that. The resulting trinomials have a leading coefficient of 1. Factoring, in this case, is pretty straightforward, where all you need to do is find factors of the constant term that also add to the middle term. And I'll assume you already know how to factor these types of trinomials on the left. The factorization on the right has more complication. The binomials contain a term with a coefficient on x. It's a bit more tricky to factor trinomials of this type, and I'll give you 5 examples in this video to show you how to get the job done. In our first example, we're looking at a trinomial, and we're looking at a leading term that has a leading coefficient that is 2, and it is not 1. So this is one of the more complicated types of factoring if we cannot factor out a GCF. And I just inspect really quickly in all 3 of the terms and I ask, can I factor out 2 from all 3 terms? And the answer to that is no, I cannot do that because 2 is not a factor in the second term or the third term. So let's create binomials that will be multiplying each other. And in the first position, I want to consider what times what makes 2x squared. And the only combination that works is 2x times x. So that's good because if there's only one combination, our lives are a lot more simple. The second thing I look at is the last term, and that's the number 1. Again, I ask myself, what times what makes 1? And there's only one combination, so I'll place the 1s there. And the next thing I want to do is create a double smiley face. See, I've got 2 big smiles here. And the first big smiley face, the 2x times the 1 makes 2x. And the inner smiley face, the 1 times the x makes x. And my challenge is there some way that I can either add or subtract these 2 terms in order to make the constant term in the middle of negative x? And if I think about it, if I add x plus negative 2x, that would do it. So if I find that combination, I'm good. All I need to do is note that I need a negative 2x, so I need to put a minus on that. And on the positive 1x, I put a plus for that. So let's just clean up our answer and without all of the smiley faces, and let's write 2x plus 1 times x minus 1, and that is the factored form of 2x squared minus x minus 1, and we're done. Looking at example 2, we're going to play the exact same game, and we inspect this first term, the leading term, and the leading coefficient is 5. And then I look at the other 2 terms and ask, can I divide out a 5 as a factor and GCF? But no, I cannot. So now I will set up my binomials, and I think about what times what makes 5x squared. The only combination is 5x times x. And the next one I've got is a 3. Now here's the trick, is either I can place the 3 and the 1 like so, or I can place another set of binomials with the same 5x and x, or I can place the 3 in the first spot and the 1 in the second spot. This will actually create a different product. So let's check out the smiley faces. So I'll do a big smiley face and a little smiley face. I've got 15x when I multiply 5 times 3 times x, and I have on the inner, I've got an x. Now, if I look at this, I look at x and 15x, you know what? There is no way I'm going to get a 2x by adding or subtracting. This one is not working. So I just cross it off and say that's not it. The next one I do, the big smiley face, the little smiley face, I've got a 5x and a 3x, and then I think, is there any way that I can get a 2x out of this? And there sure is. What I can do is have a negative 3x and a positive 5x, and those add up to 2x. And now I'll just place the minus with the 3x, the plus with the 1, and I've then got the factored form. Hooray! So the final answer is 5x minus 3 times x plus 1. Example 3, we have another trinomial, and we have a leading term with a leading coefficient of 4, which is not 1. And then we look through all three. We just have to double check for a GCF. And oh my goodness, we have a GCF of 4. 4 does divide each one of these terms. So we will pull out the 4 and see what's left behind. After we pull out a 4, we've got then 4x in the middle, and we have a 12 for the constant term. And then we look at this on inspection and we realize, oh, this leading term now has a leading coefficient of 1. So this is the more simple type of factoring, and we would just continue to factor as a binomial times a binomial, but the x squared just has us placing x and x, and we look at the last term, 12. We have options here. We could have 6 and 2, or we could have the factors 3 and 4, or finally we could have the factors of 12 and 1 to place in the second position. And we just ask, is there any combination of 6 and 2 that creates a negative for our middle term? And there is. If you have a negative 6 and a positive 2 and you add those up, you do get that middle term. So I would place a minus 6 and a plus 2, and that is the factored form for this trinomial. Because it had a GCF, it was a little easier. So always look for the GCF first. In example 4, I look at the leading term, and the leading coefficient is 10. And then I look through the other three terms, and I do see a GCF of 2 that would divide each of those terms. So I'll pull out that 2 and see what gets left behind. I have 5x squared plus 2x minus 3. And that looks really familiar. That looks exactly like example 2. So we would just continue this problem with a binomial times a binomial, set up the 5x times the x, and remember how the 3, it could have been placed as 1 and 3 or 3 and 1. And what we found out was that if you put a 3 and a 1 there, and you looked at that outer smiley face, you got 5x. On the inner, you got 3x. And therefore, if you take that combination and you need a 2x, you would have to have a minus on the 3x. So let's put that minus there, and let's put a plus right there, and then that will work. So what we have is a final factored form of 2 times 5x minus 3 times x plus 1, and we have it. We're done with that problem. On to the next one. In our final example, we need to factor a trinomial where the leading coefficient is not 1. There is no GCF, so we'll go straight to factoring with binomials. Let's start with the leading term, 4x squared. In this case, there are two products that give us 4x squared, 2x times 2x, and also 4x times x. Let's place these two pairs of products in different binomials. Next, let's look at the constant term 6. Again, there are more than one pair of factors. We could have 2 times 3 equals 6, and we can also have a pair of factors 6 and 1. Although there are a lot of possible combinations to try, we'll use our smiley faces to determine what works. Let's start out with 2 and 3. Check our smiley faces. Multiplying, we get 6x and 4x. But our target sum is negative 11x. This attempt at factoring has failed. I don't see any combination that could possibly add up to negative 11x here. So 2 and 3 with 2x and 2x won't work. And even if you switch places of 2 and 3, you end up with a 4x and 6x again. This combination is not producing our factored form. But let's not forget, maybe 6 and 1 will work with that 2x and 2x. Let's look at the outer smiley face and the inner smiley face and do the multiplication. It looks like we get a combination that is not going to produce that 11, the negative 11x that we need for our target sum. So this is not working, 2x and 2x. Therefore, we need to cross this off our possible list and move over to the right and consider 4x and x. Using trial and error, we'll now throw in 2 and 3 and check our smiley faces to see if we get that elusive negative 11x. But it's not working this time neither. We are not getting 11x as a sum or a difference. So my next thought is, why don't we switch the 2 and the 3 and see if that works? Checking the multiplication, we get 8x and 3x, and this is starting to look promising. 8 and 3 make 11, so if we put a negative on both of those, we would get a negative 11x. Let's double check that if we correspondingly put minus in here twice, that the last term when you multiply it works. So let's see, negative 3 times negative 2, the negative times the negative does make the positive, the plus 6 that is there, and we have a winner. So finally we can claim our answer as 4x minus 3 times x minus 2, and we're done with this problem. So I hope these examples help you with factoring trinomials where the leading coefficient is other than 1, and stay tuned for more great math videos.